Your bank password is going to become useless. Not in 50 years, not in some sci-fi future. In the next 5 to 10 years, the encryption protecting your bank account, your medical records, your private messages, all of it, could be cracked in seconds. Right now, 4 of the biggest tech companies on Earth are in a full-blown arms race to build the computer that makes that happen. Google, IBM, Microsoft, Amazon. Governments are pouring billions of dollars into winning this race before anyone else does. And you were never told any of this. Not in school, not in the news, not anywhere that actually reaches you. Here's the part that makes me genuinely angry. The decisions being made in labs right now, today, will change your financial security, your healthcare, your national security, your entire digital life. And the people most affected by those decisions have zero idea they're even happening. That's the gap. That's why we're here. This isn't a tech nerd video. This is a they made decisions about your life without explaining them to you video. So let's fix that. By the end of this, you'll know exactly what quantum computing is without needing a physics degree. You'll understand the race happening right now between Google, IBM, Microsoft, and Amazon. You'll know why 2026 is being called the year this becomes real. And most importantly, you'll know what it actually means for your money, your health, and your privacy. This affects everyone. Let's get into it. Okay, start from zero. Regular computers, your laptop, your phone, they process information using bits. A bit is like a light switch. It's either off or on, 0 or 1. Every single thing your computer does, every photo, every text, every calculation, is just billions of those switches flipping really, really fast. Quantum computers use something called qubits instead. Let me break that down. A qubit can be 0, 1, or both at the same time, until you actually look at it, until you measure it. Imagine a coin spinning in the air. While it's spinning, it's technically heads and tails simultaneously. The moment it lands, it commits to 1. A qubit works exactly like that. This is called superposition. But here's where it gets wild. You can link qubits together in a way where what happens to one instantly affects the other, no matter how far apart they are. Einstein called this spooky action at a distance. The real term is entanglement. When you combine superposition and entanglement, you get a computer that doesn't try one answer at a time. It explores millions of possible answers simultaneously. Think about a maze. Your laptop tries every path one at a time. A quantum computer tries all the paths at once. For most everyday tasks, that doesn't matter. Quantum computers are not going to replace your laptop for sending emails, but for problems involving massive complexity, cracking encryption, modeling molecules for drug discovery, predicting financial markets, it changes everything. That's why everyone is panicking to build one first. Right now, in 2026, 4 companies are neck and neck in what might be the most important technology race in human history. Let's meet them. Google, Willow chip. Google dropped a bombshell when their Willow chip completed a calculation in minutes that would take the world's best supercomputer longer than the age of the universe to solve. Let me say that again. The age of the universe. But more importantly, Willow was the first quantum system to achieve what's called below threshold error correction. Here's why that matters. Qubits are unstable, they're fragile. The slightest vibration, heat, or electromagnetic interference causes errors. This is called decoherence. It's been the biggest wall blocking real quantum computers for decades. Willow cracked that wall. The more qubits Google added, the more accurate the system became, instead of the opposite, which is what always happened before. IBM, Nighthawk IBM, is taking a different approach. Less flashy announcements, more practical roadmap. IBM's Nighthawk architecture is focused on something called verified quantum advantage, meaning not just beating a supercomputer at a fake benchmark, but solving a real-world problem that a classical computer genuinely cannot. IBM has publicly stated they're on track to demonstrate that this year. 2026, Microsoft Majorana 1. Microsoft came out of nowhere earlier in 2025 with a chip called Majorana 1. They're not using regular qubits. They built an entirely new type, topological qubits, that are supposed to be dramatically more stable, less error-prone, more scalable. Microsoft's claim is that this approach could eventually fit 1 million qubits on a single chip the size of your palm. 1 million. Current leading systems operate in the hundreds to low thousands. If they're right, they skip the field entirely. Ocelot Amazon is building quantum infrastructure the same way they built cloud computing. They don't need to have the best chip. They need to own the platform everyone else uses. Their Ocelot chip focuses on error correction too. But Amazon's real play is making quantum computing accessible through AWS before anyone else. Whoever controls the cloud layer of quantum computing controls who gets access, what it costs, and how fast the world catches up. This is a power move, and it's working. Scientists and researchers have been talking about quantum computing for 30 years. So, why is 2026 different? Three reasons. One, error correction is finally working. This was the unsolvable problem. Quantum systems were so error prone, they couldn't be trusted for anything real. Willow's breakthrough, Microsoft's topological qubits, IBM's error correction methods, all of them are converging on the same solution at the same time. 2026 is when multiple teams are claiming systems stable enough to actually use. 2. Governments stopped waiting. The United States passed significant quantum funding legislation. China has invested an estimated $15 billion into quantum research, officially making it a national security priority. The European Union launched the Quantum Flagship program. South Korea, Japan, India, all racing. When governments start spending at this level, they're not betting on the future. They're responding to something they already know is coming. 3. The encryption deadline is approaching. Here's the part nobody wants to say out loud. The encryption standard protecting most of the internet right now is called RSA encryption. It works because factoring enormous numbers, breaking them into their components, is computationally impossible for classical computers. It would take billions of years. A sufficiently powerful quantum computer could factor those numbers in hours, maybe minutes. NIST, the National Institute of Standards and Technology, has already started rolling out new quantum-resistant encryption standards. They began in 2024. They are doing this because they believe the threat is real and imminent. That's not fear-mongering, that's the US government officially preparing. Okay, let's make this personal. You, specifically, your passwords and your bank. Every password you have is protected by encryption. Every credit card transaction, every bank login, every time you tap your phone to pay for something, encrypted. When a sufficiently powerful quantum computer exists, that encryption can potentially be broken retroactively, meaning data that's been stolen and stored today, right now, by hackers or foreign governments, could be decrypted years from now when the computers are ready. This strategy even has a name. Harvest now, decrypt later. This is already happening. Intelligence agencies believe adversaries are collecting encrypted data today, specifically to crack it later. Your bank, your hospital, your government agencies, they all need to upgrade their encryption before quantum computers are powerful enough to break the current standard. The race isn't just between tech companies, it's against the clock, your medical treatment. Here's the flip side, and it's genuinely incredible. Developing a new drug is catastrophically difficult and expensive. Why? Because discovering how molecules interact requires simulating chemistry at the atomic level. Classical computers cannot do this accurately for complex molecules. It's too many variables. Quantum computers are built for exactly this problem. Diseases that have resisted treatment for decades, certain cancers, Alzheimer's, antibiotic-resistant bacteria, require understanding molecular interactions we currently cannot model. Quantum simulation could compress decades of drug discovery into years. This isn't theoretical. IBM, Google, and pharmaceutical companies are already running early quantum chemistry experiments. The results aren't clinically available yet, but the pipeline is being built right now. Your job market. If you're 16 to 26 right now, quantum computing will be part of your professional world whether you work in tech or not. Every industry that uses data, finance, logistics, healthcare, energy, manufacturing, will be restructured by what quantum computers can optimize. You don't need to become a quantum physicist, but understanding what this technology does, what it threatens, and what it creates, that is the kind of knowledge that separates people who get left behind from people who navigate forward. That's not motivational poster stuff. That's just true. Here's where we land. Quantum computing is not science fiction. The race is real. The stakes are real. And the fact that you weren't taught any of this in school, in the news, anywhere, that's a choice someone made. Not an accident, a choice. You deserve to know that the encryption protecting your money is being targeted. You deserve to know that 4 companies and a dozen governments are spending billions on technology that will reshape every industry you'll work in. Now you know, here's what you can do today. One thing, go to your most important accounts, your bank, your email, your phone, and turn on passkey authentication if it's available. Passkeys are already more quantum resistant than passwords. Major banks and Google and Apple all support them now. One setting change. That's it. Start there. The bigger change is just staying informed, because the people who understand what's coming are the ones who get to shape it, or at least not get blindsided by it. Follow for more of what they should have taught you.